Welcome, everyone, to the Intel Builders webinar program. Thank you for taking the time to join us today for our presentation titled Power Up Your Cloud with Insanely Fast Storage. Before we get started, I want to point out some of the features of the BrightTalk tool that may improve your experience. There's a Questions tab below your viewer. I encourage our live audience to please ask questions at any time. Our presenter will hold answering them until the end of the presentation. Below your viewing screen, you will also find an Attachments tab with additional documentation and reference materials, including a number of sites and documents mentioned in this presentation. Finally, at the end of the presentation, please take the time to provide feedback using the rating tab. We value your thoughts and will use the information to improve our future webinars. Intel Builders webinar series takes place live every week, so check the channel to see what is upcoming and access our growing library of recorded content. Today we are pleased to welcome Boyan Ivanov, CEO, StorPool Storage. Boyan helps companies build new-age public and private clouds. He co-founded StorPool Storage with the belief that storing data should be faster, simpler, and cheaper. Prior to StorPool, Boyan has worked in both small and large enterprises and has also started several companies. Welcome, Boyan, and thank you for taking the time to join us today.
Well, hello, and thanks for having me. So, thank you for joining this webinar. And in today's topic, I'll just go straight to what we're going to talk about today. And this is a talk for a company that's building or managing a public or a private cloud. And as a company that's doing this, you're looking for ways to differentiate from all other companies or services on the market. So we'll talk about that, and we'll also talk about how to build fast, reliable, and cost-efficient service, just because this is the essence of building a cloud. It has to be up all the time. It has to be fast so users can do their job as fast as possible and don't complain about delays. And it also has to come with a reasonable price tag. And here we're going to showcase a solution that we built based on Intel technologies. It's an actual solution that's run by a number of companies. And in this particular case, it's also a solution brief we did with Intel. And the end customer was a Spanish service provider company that's doing public cloud services. So we're going to show this as kind of like a small foundation that you can have in your cloud to deliver fast, reliable, and cost-efficient service, but then it can serve as the nucleus of your petabyte-scale cloud. So it's a very interesting and powerful concept. Now, when you're building a cloud, you're thinking, okay, how can my private or public cloud be better? And the answer to this is, on the technical side at least, you have to innovate and adopt new technologies in order to make the service, in the first place, faster, because this is the most common complaint of customers or the most common request of companies or users coming to you and say, hey, my Windows VM is slow, or my workload is not as fast as I would like it to be, etc., etc. The other thing that goes without saying, but I think is equally as important, is you have to eliminate any downtime. And this is we call feature number 0, and not many people, most people try to avoid the topic, but obviously your customers or users become upset the most when your service is not available. So you're doing everything possible to virtually eliminate downtime. The other thing you can do to have a cloud offering that's different than anybody else on the market and is better is to have more features, to have systems that don't need restarts or upgrades go seamlessly for the end user, and all these things that you can do on the software or on the usability level of the service. And of course, as the company that's managing or building this cloud, you have to cut costs. You have to contain costs in order to have higher margin or to have the resources to reinvest in your business and grow the business, improve the service constantly, so you can stay ahead of your competitors. And here we want to showcase a practical example of what fast service means and what it doesn't mean. And this is a screenshot from the MySQL of one particular customer. This is actually the customer of one of our service provider customers. So our customer is, in this case, a Swiss MSP who is doing only enterprise customers, and their end customer has this SQL workload, and they came back to the Swiss service provider saying, my VMs are running slow. I'm seeing latency, the performance is not as it should be. And together we worked with this Swiss service provider to tune and optimize the storage system. In the end, it ended up being a StorPool powered software-defined storage system. And in the process, we were able to reduce the latency about tenfold. And this is when you get a happy customer, business benefits as less support, time and effort, more word of mouth growth for your business, and customers that just recommend your service. And this is how you measure latency or performance, and you can extrapolate this, because if you have, for example, a typical virtualized environment which is running many VMs, usually there is a database in each of these VMs in the end, and each of these databases produces, hundreds or thousands or tens of thousands of IOs. And if every single transaction has a lot of latency, this just adds up. Even if you put the simplest case where you have a virtual machine with a website in it, and you open the website, there are hundreds or, in some cases, thousands of queries to the underlying database. And if each query is like 1 millisecond long, this is taking too much time to load, and the user experience is not that great. And I think 1 millisecond is the threshold that you should aim. Everything like for production, primary storage system, anything that delivers above millisecond in our view is too slow. And we aim to do something in the region of 100 to 300 microseconds. That's a third of millisecond, the most. Now, the other point is eliminating downtime. And I think people don't realize that if you build public or private cloud, the only way you can practically eliminate downtime is to have a shared storage system. It boils down to having a shared storage system. Unless if you're using local storage system or local storage or anything else, this will be a system that would go down for planned or unplanned maintenance. Like if you have a hardware failure, a server fails, network goes out, you have downtime. If you have to upgrade kernels, if you have to update software, you have restart of VMs and all the workloads if you don't have shared storage system, which can do like migrations, high availability. Now, an upgrade to the shared storage system, you can have it from a SAN vendor that provides a SAN storage array or all-flash array or hybrid array. But this imposes vendor lock-in is quite expensive. So if you're using distributed storage, like software-defined storage, that's going to be faster, cheaper because of the built-in high availability of the system, self-healing. Anytime you build a software-defined storage system with 10 standard nodes, you're adding 10 times the RAM, 10 times the CPU power, 10 times the networking interfaces. So it's ultimately way more redundant than a single box that has two controllers. Like if you have 10 server SDS system, it has 20 controllers because it has 2 controllers per storage server. So 10 servers are 20 network interfaces, which is a way more redundant system. On top of that, it's faster and it's more cost efficient. For downtime, the norm nowadays is to have all maintenance and upgrades online on a rolling basis without causing any downtime. In many cases, your end users or customers wouldn't even know that you're doing an upgrade of the system. So you don't have to plan this complex and cumbersome updates or maintenance windows to your customers to let them know that there is a date, etc., etc. So it all goes transparent to the end user. Obviously, hardware failure and refresh cycles become much easier. They become kind of like a thing of the past. If you have to do a hardware refresh, just buy a bunch of new servers, you plug them in the infrastructure, you rebalance on a rolling basis, you take the old hardware out. So you don't have to do white migration, you don't have to do like restarts of the system, you don't have to do migration of the data from here to there. It kind of happens seamlessly while operations are running on this cloud. On the front of how you, as a service provider or cloud operator, manage this system, you're thinking also for something that's not customer facing, and this is how you're scaling the system. And scale out is becoming the norm. So you want to be able to scale the system both in capacity and performance linearly, or as close to linearly as possible, with any new server or component that you add to the system. And again, this is an online operation, but you can mix and match. Do I need more performance? I can add more IOPS. Can I add more capacity? In most cases, you add also performance, but this is what you can do. Again, non-disruptive. Again, all the scalability of the system is done online. And this is not only for increasing your cloud capacity, but also for day-to-day operations. This is for expansion or shrinking of volumes. If you do white migration of a particular customer VM, which is becoming too big for one host, you can white migrate it to another host with the shared storage functionality, white migration enabled. You have the flexibility to utilize your resources to increase the utilization of your hosts or your entire stack because of this mix and match fluid functionality. And here we want to present a particular implementation of these concepts, how to build a fast, reliable, cost-efficient solution. And in this case, we did this with only Intel standard x86 platform. We're using StorPool, which is by far the fastest block level software-defined storage on the market, and it also really efficient in terms of how little CPU and RAM it consumes on the server. So you can have low-spec servers, or you can hyper-converge if you like, which also brings down the cost of your cloud offering. It reduces vendor lock-in, no SANs required, even though this solution, even at the smallest configuration that we've tested here, provides performance that is faster than almost all flash arrays that you can currently buy on the market. So it starts at 500,000 IOPS, so 500,000 IOPS, and it does 200 microseconds, so a fifth of a millisecond of latency under moderate load. And this has business benefits. Basically, it reduces the total cost of ownership for the cloud provider, and it also makes your job easier. It reduces vendor lock-in. You don't have to manage fiber channels and separate gear. It's just like standard Ethernet, standard Intel. It's very simple and straightforward. Here is a small diagram of the solution. It consists, on the right side, you see hypervisors or compute nodes which are running VMs. And in this case, we said, like in the first version, this is now deployed in many cloud service providers and private clouds around the world. But like the first implementation that we tested was for a Spanish service provider. They started with 5 hypervisors or compute nodes that were using for running customer VMs. On the other side, I had 3 standalone storage nodes against low-spec standard servers. They had initially just 4 SSDs per node, and this means 12 SSDs in total in 3 servers, 3 nodes. And these servers were connected with redundant 10 gigabit Ethernet, standard Ethernet network, which served 2 purposes. One is it removed any single point of failure because we had a distributed storage solution on the left side, powered by StorPool, which doesn't have single point of failure. You have many hypervisors and white migration on the software stack, and then you're moving the bottleneck to the network. So we have two switches for redundancy. We also do load balancing through the same switches, and we also double the bandwidth because we use them as two separate switches. So two 10 gigabit switches, we have 20 gigabits throughput in the system. So you can find configurations that the customer provided or used in this case. There were Dell servers because this is what the customer had. For the storage servers, on the top side, you had Intel Xeon E3 processors, just 32 gigs of RAM per server, so extremely efficient on the software side in terms of how much resources it needs. It was powered by Intel S3510 standard SATA SSDs, data center grade with power loss protection, so very, very good equipment. 2 times 10 gigabit Ethernet network. And on the compute side, they had Intel E5 processors, more powerful machines, so they can have more VMs running on the compute nodes. A bit about the StorPool solution that was powering this cloud is StorPool is a next generation data storage software. It's built for companies that want to have cloud that starts small but can grow in the petabyte range and are way better than anything that's available on the market today. It's meant for clouds and enterprises that want new age clouds, API driven, fast, reliable. It runs on standard servers and standard hardware and delivers block level storage. So we do one thing, we specialize in it, and we do it better than anybody else on the market. And in our case, this is block level storage, but it's standard block level storage. It appears as a SAN to the hypervisor or the OS on top of StorPool. I think the unique thing about this solution is that it's built from the ground up. So it's fully distributed, shared nothing architecture, no metadata servers, no active passive controllers. It's kind of like a piece of art. And the result is, one, it just works. A lot of storage solutions, software storage solutions have been out there for quite some time now, but they have issues in terms of reliability, scalability, performance, and I think StorPool, one of the big differences is really, really simple. So it just works as expected. It delivers what other solutions promise but fail to deliver. So it just, you put it, it works. And the other thing, of course, the result of all the effort is it's unmatched in levels of both performance in technical terms like IOPS, megabytes per second, but also efficiency, how little resources it consumes on the servers, and of course, how robust the technology is. Here is like a small diagram of how a typical deployment looks for any cloud. It starts with a minimum of 3 servers and it can scale. On the bottom, you have SSDs or a mixture of SSDs and HDDs in these standard servers. You have the StorPool software installed on these servers. It forms a shared storage pool, which is like the first kind of rectangle on the bottom, the green one. Then you can reuse the same servers for hypervisors if you're in the KVM Zen stack to run VMs. If you're in the VMware Hyper-V Windows worlds, you connect through iSCSI to this shared storage service. And you can have both. You can have this cluster that's running hyper-converged for Linux, OpenStack, CloudStack, on-app workloads, and then still expose storage service to legacy stacks like Hyper-V and VMware through iSCSI. In this system, we have tested 12 SSDs, standard SATA S35 and SSDs from Intel, 2 copies of data. The tests were performed on all 5 initiators to see how much the system can handle in terms of performance. We used FIO performance test to measure performance on the block level side. And here is like the Linux kernel version we used, and the StorPool version is our previous version. So we have kind of like faster, more feature-rich version, but this was done in the beginning of the year, so it's the old version. The results, I think they speak for themselves. We have above quarter million IOPS in random write and about 500,000 IOPS in random read. I think I have them in a table. Okay, here is also the table. And these IOPS and megabytes per second are actually limited by the number of hypervisors in this cluster. In the beginning, we showed that the customer started with 5 compute nodes and 3 StorPool storage nodes. And these 3 storage nodes can provide even more performance, but there were not enough clients of the system to request this performance. So this is the performance that we measured from the initial setup with 12 SSDs in total and 5 compute nodes that were asking for IOs and hammering the system with IO and then the sequential workloads. Even then, it's an extremely capable system, even at the smallest scale you can have. Another interesting thing, we started with performance, and for most workloads, especially for databases, and as you know, most applications, web servers, everything in the end, they hit the database. They're latency bound. People and other storage vendors tell you how many IOPS they do, which is important to know. But in most cases, it's the latency that determines how fast your storage system is, how fast your overall cloud is, and how happy your customers or users are. And as you said, it multiplies by the number of requests each VM does to the storage system, and these are hundreds. It also scales with the number of applications you have running on this cloud infrastructure. So here we've measured latency versus IOPS, and this is on the one side, we start pushing the system to do more and more requests, and we measure how the system will, how the system latency will change. And you can see this system starts with about 200 microseconds of latency and to about 100,000 IOs. So you start hammering it with IO, it's still about 400 microseconds, which is impressive for such a small system, and especially for a system that you try to load, and it keeps very high level of performance. So it even peaks at about 150,000 IOPS, still under 1 millisecond latency, which is very impressive for such a small system. And it also is something that is not a function of how big the system is. Like if you have 10 times bigger system, the latency metrics will stay the same. It is how much the pressure you put on the system, how many IOs you request from it, that actually determines if at some point you get congestion somewhere across the stack and you start seeing latency go down. Here is a table of the results that were visualized on the other graph, but you can find this in the reference architecture. That's one of the attachments and links. So I'll just leave that for if you want to review it, you have it. Here is some recommendation when you using software-defined storage solution. It could be StorPool, could be anything else. And one of the most important things that we've seen is that people use consumer-grade SSDs to do business, and consumer-grade SSDs were not designed for this. So in our, we always use data center-grade SSDs because they have power loss protection, which delivers two very important things. One is safe fail if the power goes out, so you don't lose data, you have no corrupted data, all of these things that you cannot allow to have in a enterprise-grade solution. And also some of the consumer-grade drives have throttling, which means if you try to push a lot of I/O, the system will prevent you from getting all the I/O to preserve endurance of the drive. That's on spec sheet from the producer. So this is why you always use data center grade drives. In this test, we used S3510, but you can as well use some of the newer versions, which are also very good drives and very cost-efficient drives. Another thing for the storage system, again, we use very efficient Xeon E3 processors. The test was with V5, but now the V6 is out, and you can get it fast, just single core, high megahertz, gigahertz, and it's fast and efficient. For the compute side, if you decouple storage and compute, get powerful E5 processors or Xeon scalable, because it will give you overall efficiency and cost reduction on the compute side for a cloud offering. It's basically better unit economics. This is what it boils down to. So particularly for this system, how you can, what you can expect from this type of system in terms of price performance and cost efficiency. In this case, this was a small flash system. Shared storage delivered about 8.7 terabyte usable. And on this 8.7 terabyte usable, depending on what is your software stack, like hypervisor and cloud management on top, you can provision maybe 2 to 3 times as much disk space in the virtual machines. And this is due to the space-saving features that are in the storage software. So I have things like team provisioning and snapshots and calls and templates and trim discard and zeros detection. So if you have 17 terabytes of logical or provisioned space in virtual machines, it will actually take about half that space or less on the actual storage system. So you have a gain there. This solution at the time was about $35,000 for both hardware, software, and support, licenses, proactive monitoring, SLA-based support for 3 years. So this was the total cost for 3 years, which is extremely low investment for getting started with a system that's delivering 500,000 IOs and can be the foundation of your differentiated cloud offering. This was about $4 per gigabyte usable and 7 cents per IO, which is by far the lowest dollars per IO I've seen kind of referenced in papers of other that are on the web. So I haven't seen anything that's lower cost. And this is when we started with the system with just 4 drives. But this system scales linearly and with small steps. The first upgrade is just filling the empty drives in these existing 3 servers, which doubles the capacity, the usable capacity, and reduces the cost because you have the 3 servers and we occupied only 4 of the drive base. If you have 4 more drives, you increase the capacity, so your overall price per gigabyte decreases because of economy of scale. But then you can grow this system by adding more servers to the storage system, so you can scale it in the petabyte range. Again, in this case, it will go to millions of IOPS and again with sub-millisecond latency. So this is a solution that if you want to do one thing that will have an impact on your entire public or private cloud, this is one thing that it will do it. It will, it's kind of like a conclusion, but using a solution like that can differentiate your cloud or offering from anything else on the market. It's going to be faster, it's going to be more reliable, it's going to be in the end cheaper as total solution cost, but will provide performance that people want to use and want to recommend to other users. And we've seen this with some of our customers who are attracting users or enterprise customers from Amazon and Google and Rackspace and the like the hyperscale giants, just because their service is faster. And it's consistently faster. It's all the time you measure it, it's consistently faster. And this is sometimes 3-4 times faster. So this is really the competitive edge of how some of the customers, by providing better product, they get business benefits. They have better performance, more reliable system, no downtime, and they have business benefits by less support effort, less tickets that they have to take care of, etc., etc. So I think this is kind of what we wanted to showcase, like a simple one-step solution that can directly help you. And with this, I would like to thank you. And I think we also have some questions. So Renee, would you cover these or?
Sure. Yes, we do have some questions, Glenn. The first one is this solution available with servers from other vendors?
Definitely. So StorPool and most other storage solutions are not dependent on a particular server vendor. So in this case, the customer was using Dell, but we have in production servers from pretty much any vendor that you can think. So we do qualify components by type, like SSD, CPU, HDD. But this is per component, so regardless of if you're IBM, Lenovo, whatever type of server, you can have it. So Dell, HP, IBM, and Lenovo was not a good example, was it? So this doesn't matter. So basically, we qualify components as long as it's a standard x86 component. We might use it. Of course, we have a recommendation of hardware that we've tested in our lab and we know will work fast and will be reliable in production. And it's easier to stick with those. But you're free to choose any type of server you'd like.
Thank you. Is performance scaling out with the number of servers?
Yes, I think I mentioned this briefly, but it's a totally scale-out system, which is not something that your customers see, but if you're the company that's operating a cloud, that's crucial for you. So one is capacity scales. So if you have a 5 terabyte database and you have to grow it to 10 terabyte and your storage system is only 7 terabytes, you don't have to do migrations. You put more hardware, the capacity grows, the IOPS also grows. Because as I mentioned earlier, you add more CPU, more RAM, more network interfaces, so your performance grows linearly as much as you need.
Thank you. How do you manage the system?
So the system is managed in two ways. One is we provide, I think, differentiated compared to any other storage vendor on the market. We provide a working solution. So it's kind of like a managed storage solution in your data center on your servers, but it's not a black box. You can do everything if you'd like to, but we just try to offload your technical staff so you can put them to work on revenue generating activities and bring more business, do what you're best at. So we install the system, and usually it's managed through an API, which in most cases is integrated with the cloud management system that cloud builders are using. Like we've seen OpenStack and CloudStack, and ONAP is popular in hosting. We have OpenNebula, you have Proxmox, you have different type of solutions. Like in cloud, large scale clouds, it's usually some form of open source Linux technology, but you also have their share of VMware and Hyper-V. So one way to manage the system is through the API or CLI. You have a kind of like a PowerShell for managing the system, but in most cases, it's just integrated in your cloud management system. You have a single pane where you go and you manage compute resources, networking resources, storage resources, so you don't even touch the storage system. I think it's usually when we install it, but that's kind of to simplify your needs. But it's all scriptable, programmable, it's API driven.
Is this solution available with NVMe drives?
Okay, that's a very interesting, very popular question lately. And I think this is something that's new for 2017. Like last year, I think we had like for the entire 2016, just a couple of vendors, a couple of customers asking for this. And this year, I think pretty much any new customer is asking about NVMEs. And definitely, this system is capable of running NVMe. So we actually have NVMe powered clusters in production. They can deliver about half the latency, so about 100 microsecond latency. Our clusters are using RDMA capable network that's usually faster. It's 25, 40, sometimes 100 gig. And it's also RDMA capable. So it basically shaves off some of the latency. However, also NVMe drives are going down in price to the point where they're becoming almost the same price as SATA drives. So it would make sense to make NVMe drives, to use NVMe drives. The question is, one, do you really need that performance? Even if you have just a small premium, is it worth paying it unless your use cases really need it? And the second one, currently the SSD shortage is continuing with full force, and we thought that by this year it's going to be better, like more fabs going in production, but the SSD crunch is continuing and it's increasing, I think, in impact. So availability of NVMe is really, really tight. So it might be an interesting idea if you have it available and the price is good, go directly with NVMe. But my experience, you'll be looking at short availability and long lead time. So in this case, a SATA system will provide more than enough performance anyway. So it's up to you.
One last question. How do we implement this?
Okay. That's a very hands-on question. So it's from a cloud service provider or from a cloud operator point of view, it's rather simple. You just order new hardware that matches. Ideally, contact a vendor. You can contact StorPool, will help you with what type of hardware to select. Basically, we'll try to understand more about your business without recommending something that might not be a good fit for you. We'll actually come, unlike many other vendors, we'll just come and we'll say, okay, what is your use case? What are your type of customers? What level of performance you need? How many terabytes of space you need? And we will design a software-defined system around that with your selected hardware vendor. And then you can order hardware, have it in your data center. We log in remotely to set up the system. We connect it to your workloads, and then you can use it. In some cases, we also do migration of your old infrastructure to the new stack. So we'll help with that. And in this case, it's a process that usually on the StorPool part at least takes about a day to have a solution up and running, provided you have a good hardware that's already available. It's usually 1-2 days of work. Otherwise, I think procurement of hardware, you can safely say 2-3 weeks from what I've seen, because there are every now and then small issues with the hardware. So you're looking for, less than a month project if you want to have the entire solution to upgrade kind of your cloud.
That's all the questions we have for today. I'd like to thank Boyan for his informative presentation, and I would like to thank our audience for joining us. Thank you, and have a good day.
Thank you. Bye.